Hey guys, today is day 13 of Leetcode challenge, and today's question is: given a binary array, find maximum length of contiguous subarray with equal number of zeros and ones. Here, example given is an array of two elements, 0 and 1. Both have, so this array has, and actually the subarray has equal number of zeros and ones, so they return 0. Here, this subarray has two elements and equal number of zeros and 1, so it returns 2 here, right? We need to find the maximum such subarray. I think first thought that comes to our mind is using a stack where we can push zeros on the stack. And whenever we see a 1, we pop out a 0 from the stack. And in this way, we can also store the indexes on the stack where we have seen the zeros and an index of 1, and probably can do a max on j minus index, right? This is analogous to the problem where you have braces and you need to find the maximum, the array with the longest subarray, which has the matching pair of braces. But in this question, if we replace 0 and 1 with these braces, we also need to take care of the fact that the opposite braces, this is also a valid combination, right? So probably we need to store like two stacks, one of zeros and one of ones. And if both of them are empty, then we need to start populating either of these depending on what number we see and pop from the opposite stack. But the solution can get messy real quickly. Another simulation, such as the braces, another simulation we can do is instead of replacing zeros and one, to braces, we can replace 0 with -1 and keep the 1 as it is. So how does it transform our problem? This transforms our problem now to finding longest subarray with sum equals to 0, right? Because if we replace 0 with -1, then equal zeros and 1 mean the sum of the subarray is equals to 0, right? Again, so this actually transforms our problem into a simple prefix store and find problem. Prefix store and lookup, right? What do I mean by prefixes? So you have an array of -1s and 1s now, right? And you want to find the longest array. So what we can do is we can run through this array and find the prefix sums, which means this cumulative sums of these of this array here: 1, 2, 1, 0, and 1. Now we see any prefixes that are equal, which means this and this and this. So the sum between these two indexes is always 0 because you have sum the elements up to here, then the sum is equal to 1, and you have also summed elements up to here which sum is equal to 1. So the elements sum between this part should be equal to 0. So what we can do is we can run through this array, get the prefix sum, check if we have seen this prefix. If yes, then we have n subarray with the sum 0, and we can just do a math of it. So let's look at this in code. Okay, let's code this in Python. I store the length of nums in n for easy iteration. Now replace zeros with ones, with -1s for I range n. If nums of I is same as 0, nums of I equals to -1. Okay, let's store prefixes. This is in dictionary. Okay. Now we iterate over the array. We maintain a total which is equals to current prefix I in range n. What you do is we update a current total equals to nums of I. So this is our current running count. if we have seen this total, first of all, if total not n prefix, this is the first step we should do, right? Because that will happen for the very first element. So what do we do if it is not there? So what we'll do is we'll store this total or the prefix in the dictionary, and the value should be the current index, right? Now, if we have already seen this sum, this total, then which means we have a subarray whose sum is 0. So we need to find out what was the index of previously seen starting point of this subarray, which is prefix of total, minus it from I. So this is actually the length of prefix, length of the subarray, which has the total as 0, right? And we just need to store it in our answer, right? And we should have multiple answers, so we should do a max over it and do something like this. Now we also need to declare answer here, and in the end we will return our answer. Okay, simple. Now there is one problem here, that what if we have a example like this, right, where we have 0 and 1. So we haven't seen or this would be transformed into -1 and 1, and the prefixes would be -1 and 0, right? We haven't seen 0, but we know that this is essentially the sum from the starting point. So as a placeholder, what we'll do is we'll put a prefix of 0 as -1 over here, right? Which means if we see 0 here again, this is the 1th index, then our answer becomes index I equals to 1 minus of -1, which is equals to 2, right? So this placeholder saying that start of the array has sum 0, or index -1 has sum 0, and this not to be confused with -1 indexing of Python. Okay, great. So let's try to run this code. Expected. Let's try to submit this code. Okay, cool. Then complexity of the solution is probably order n into hash table lookup. It depends on the type of language you implement and what sort of hash table you look, but more or less we can say the hash table lookup will end up in amortized time, order 1 or constant time, and the storage or the space complexity of this algo can be order n, where we store all the prefixes if we have an example 000, right? So this will actually everything will go into the hash table. Okay, thanks for watching this video, guys. Comment on it, share if you like the video, subscribe to our channel. Thanks again, and bye bye.